Hello everyone. I wanted to give you a work-in-progress update of where we are with Project Eureka. As a reminder, Project Eureka is designed to build on what we learned from our customers and partners with Cloudy Cluster, where it focused on cross-cloud specific HPC and interactive applications. Project Eureka focuses on an integrated approach to interactive applications, computational workflows, and integrated storage management. The development team has focused on an inside-out process, focusing on the day-to-day use cases first, then adding less frequently used features. This enables refinement of those items frequently used. With that in mind, this overview shows the status of the project-based UI that has been developed on top of Open OnDemand. One of the goals of this part of the Project Eureka is to provide a project-based interface so people can collaborate with users across interactive apps, storage and compute from HPC to AI and beyond. See, with this interface, a researcher, data scientist, engineer or AI specialist can view their various different projects. And here we see two projects, laminar flow interactions and macromolecular structures. In this overview page, we can see how many collaborators, what is running, and how many instances, cores and GPUs are being used along with the status of sessions and jobs. And let's go ahead and pop into laminar flow interactions and see what kind of activities are going on. Previously, I started 3 application launchers. There are various different launchers and we can configure a Linux desktop, VS Code, Jupyter, OpenFOAM, and really any other interactive application. One of the key aspects of Open OnDemand we are leveraging is the ability to remotely access any of these interactive applications from a browser. So let's say we want to connect to this Linux desktop, which has all the access encrypted and sits behind the login node, which acts as a bastion host. Now that we are in, we can see how responsive it is. As example, we can open up a file view and see my home directory and the various different files. And what is really cool is the same home directory mounts across all of these applications and HPC or AI workflows. So if we go into VS Code, which is already running, it has the same access to files, and the same with Jupyter, all providing a seamless workspace. So let's drag and drop a file named app template into Jupyter, and we can go back to our desktop session and hurry up the refresh process. And there's the app template so easily accessible from all of your various different applications and workflows. We also have the ability, on a per project basis, to create managed buckets, so this would be a GCS bucket, because this is connected to Google Cloud. So let's create one. It has to be unique across all of the buckets globally. I added the initials to make it more unique. Internally to Eureka, you don't have to call it the big long name. We can call it out LFKBW or input output or whatever we would like. So with that, it will start provisioning. And after it's done provisioning, it will automatically configure the bucket in Eureka, including iRODS for data management, and be available in the Eureka Storage UI. And the Storage Manager in Project Eureka will provide the ability to manage files and directories across storage systems. If we take a look at the macromolecular project and go into the Storage Manager, you can see inputs there, which is associated with the macromolecular input bucket that was created previously. There are already a set of folders, and you can easily create a new folder, say, blah, we can. If we want to move it into my dataset too, it's an easy drag and drop. The capabilities of the Storage Manager will continue to advance as we move through the development process. The ultimate goal is a project-wide view across the project storage resources, so we can go back to the laminar flow interactive applications page, and we can see that they are all up and running. To give you an idea of what it takes to add a launcher, let's select Add Launcher. From there, you can select from a list of applications that have been configured in Project Eureka. So if we choose RStudio and we want to use a GPU with it, let's update the name. So project members will know this uses a GPU when they launch it. And now it's ready to use. With each running application, you have the ability to pause it also. Pausing an application will stop the instance from running, but keep its local storage intact. So if you added libraries, data, or extra software, it will be waiting for your return and turn it back on, and you won't have to reinstall every time. When you are completely done using an application instance, you can end it. This will stop it and also delete all the local storage. So we will go ahead and end all of these, since we are done for the day. There are a couple more things that I think you might find useful. Let's go ahead and show how we can create a project, select New Project, then let's choose a name, say Sample Project. Notice the project directory is auto-named. Leave everything else default and add some collaborators, David, Kristen, and Amy. Choose their roles and select Add. Now we can quickly add a launcher. Let's choose a Linux desktop and keep everything else to its defaults and select Add. Now we have a sample project with a desktop application launcher, and when we go back to the project's overview page, we can see all three and the status of my applications in those projects. You also have the ability to web SSH into the login node, where you also have your home directory mounted and can access it similarly to how you did with the applications, and you can do everything you normally do when you're SSH'd in, making it all accessible easily from within the same user interface. I would like to thank you for spending some time with me on the Project Eureka update. Have a wonderful day.